This is problem 628 from your textbook. I went ahead and drew the problem. Um, they want us to find DE, I'm going to highlight them, to find DE, GH, and EH. And so we see just from that, so we could solve it using a method of joints and do joint F, and then joint E. Could we do E? Yeah. Because if we see this is going to be a zero force member, so we can do joint F and then joint E, or we can do the method of sections. We're practicing a method of sections now, so I want you all to do method of sections for this one. But for method of sections, we just want to draw a cut through as many of the unknowns, but we can only handle 3 unknowns, so that works. So the 3 that we need to find are all on that same plane, so we can just cut it there. For this one, we do need to solve for the reaction forces. I think I'm going to take the left-hand side. So I'm going to focus on the left-hand side. And so for that, I need to know what's happening at that roller. So to do that, I'm just going to do a free body diagram. I'm going to copy this whole thing. Make it a little smaller. But basically, I'm just going to remove the 2 reactions and replace those with forces. So we have the normal force at F. And then we also have at A, we have AY and AX. Since we're going to take the left-hand side, we just need that normal force at F. So for that, I can just sum the forces in the Y direction. Or no, the sum the forces in the Y direction, I have 2 unknowns. So I need to sum the moments about A. So let's sum the moments about A equals 0. And so that we'll just start going up here. So we'll start with this force here. So we have 40 kilonewtons, and that's going to create, I'm using the right hand rule, so it's going to create a positive moment. So 40 kilonewtons times 1.5 meters is a moment arm. And then the 30 kilonewtons will also do the same, times 3 meters is a moment arm. Should be putting units for all these, but so each of these is kilonewtons times meters. Then that 150 or that 50 kilonewton force is in line with point A, so it has no moment arm. Then we have the 40 kilonewton force, which using the right hand rule will also create a positive moment. So 40 kilonewton force times, and that moment arm is 2 meters. And then minus that NF times, and that would be 4 meters, equals 0. So we get NF equals, I'm going to calculate this out really quickly. Get 57.5 kilonewtons, and I got a positive number, so I guessed right about it being pointed up. So now we have the normal force here. So now we can look at the right hand side, and we just have 3 unknowns. So grab this. I might make it a little bigger. And we found that normal force to be 57.5 kilonewtons. So you see now I'm just like cleaning this up a little bit. Like that, this, and this. This is where we just cut that, and then we need to put forces to replace them. So we have DE, we have EH, Um, and then we have GH. Um, and then we also know that this whole thing is 1.5 meters tall. For that E to H, we'll need to go down 1.5 and over 2. If we multiply those both by 2, we'll go down 3 meters and over 4. So it's 3, 4, 5 is that common triangle or that ratio. And we know this is the zero force member. We already had it marked. I think that's it. So now we can just use our equations. So we can sum the moments. And usually I do the moments about the point with the most unknowns, which that would be point E equals 0. So if we do that, we have this 57.5 kilonewton force, which will create a negative moment using the right-hand rule. So negative 57.5 kilonewtons times 2 meters is the moment arm. And then we're doing these about point E. Then we also have GH. If we do the right-hand rule, that creates a positive moment. So plus GH times 1.5 meters. And then the last forces are all at point E, so they wouldn't have a moment arm. So those wouldn't create a moment. That equals 0. So we get GH equals 76.7 kilonewtons for GH, and I got a positive number, so that means we picked right. It is in tension. Now we can sum the forces in the x or the y direction. We see that DE and EH both have x components, whereas EH only has a y component. So if we sum the forces in the y direction equals 0, we'll only have one unknown. So that we have 57.5 kilonewtons. I'm starting with that force at F. GH is in the x direction. We have that negative 40 kilonewton force up at E. And then minus that y component of that EH. So that would be 3 over 5 times EH. That equals 0. So we're going to get EH equals 29.2 kilonewtons. And that is positive, so that means the tension was correct. And then the last one we need to find is that DE. So now we can sum the forces in the x direction. And with that, we get DE is all in the x direction. So DE plus that x component of EH. So that would be 4 over 5 times EH plus GH equals 0. So DE is going to equal negative 4/5 of EH, which is 29.2 kilonewtons, minus GH, which is at 76.7 kilonewtons. So DE equals negative. So we get 100, negative 100 kilonewtons. So because we get that negative sign, that means that we picked wrong. It's not in tension. So DE equals 100 kilonewtons in compression. So now we'll go back up to the problem statement. They asked to find, we need to find DE, GH, and EH. So DE, EH, and GH. So we're done.